Welcome back to the channel. My name is Timose from Timosora Advisor. Have you ever wondered how a coffee bar can operate even when power goes off? In today's video, we are going to connect a powerful 6 kilowatt inverter together with 4 batteries of 200 amp hour gel batteries. Have you ever wondered how they can give power backup to this coffee bar? If you're interested in solar backup solution, so this video is for you. Watch until the end of this video because I'll be sharing technical tips and how to use this system automatically without any possible delays. If you are new here to this channel, please subscribe to the channel, like our video, and turn on notification button so that you don't miss our future practical installations. Let's get started. Yes, hello my people, as I told you today, we are going to start the installation. So far our battery rack is ready, the cabinet is very clear as you see. I can open for you. This is where we're going to put the batteries: battery 1, battery 2, battery 3, battery 4. As I told that you have 4 batteries, as I show you here, and they are here. We have 4 batteries. Each battery is 200 amperes, so it means we are going to have 400 amp hours because you have an inverter of heavy. So right now here, we are going to put the batteries here in this battery cabinet. So as I told, this is a modernized cabinet. It is made by fabricators, but according to the design, have made it very well. It can roll because it has rollers so that for easy movement in case of any maintenance. So the inverter is going to be pressed here as you see. So this is the inverter where it is pressed. So we are going to make the termination from here, then it enters inside through the batteries. So this is the good designing for this installation. So we are going to press this cabinet here after putting the batteries. So the inverter will be protected very well because it has these guards. So no interruption, no short circuit, everything is going to be professional. So let's put the batteries as I showed you in this battery cabinet. We start the installation step by step. So don't miss this video, watch until the end. This is our good battery. As you see, it is 200 amp hours. It is a good battery. This is a good battery for installations in residential homes, anywhere. It is good for you to be using. So there is enough space so that you can move your battery, so that no interconnection with the battery whenever it is reacting, whenever it is charging. So the space is enough for the battery to get enough ventilation inside. So it is not squeezed. So it is in the middle, but the space in between is enough for each other. So this is a bit heavier than lithium. So you have to be energetic. So I can tug of war. The highest height to lift the battery on this cabinet. So far we have finished. No, these other steps are easier for us to install. So you see how we're enjoying. Wow. Thank God that we have put the batteries inside. They're a bit heavy also, but also we are energetic. Yeah? So we cannot fail, you know. So right now, this is how the cabinet is going to be closed safely. So that's how it is looking. It is a very good. I told you it is having these rollers. In the case of maintenance, it is now heavy more than 200 kg, but even it can move. So it means this is a professional fabricated cabinet. Move it in any angle so that no tension, no friction. You see. So in case of maintenance, you can open and see your batteries. Are they safe? Are they overheating? Are they doing what? Anything. Okay. So this the next step, we are going to do the interconnection. That is the crucial step for you to see how is it going to be connected. I told you this is a 24 inverter system, but you're going to connect in a professional way so that also you can understand. Yes, in battery connection, you're going to use a 35mm cable. This is a DC cable. Why we use a 35mm? Because of overheating, charging and discharging. The cable has to be thick enough so that you don't overheat the batteries. Even the cable cannot overheat. The result is fire, right now. So we're having battery cable rods. This one, each one, we're going to connect to each cable of the battery. So it means we are going to use 2 on each battery. So this cable, we're going to plug it on every battery. you have to make a set connection, two pieces set connection, then we make a parallel connection. Okay, let's go. So we are taking the measurements so that we can loop each battery to each battery in a series connection, positive to negative. So you have to first adjust, we have to first measure this cable because already it is wrong. So we're going to take the measurements for each battery from a negative to the positive. We have to bring the cable from here up to here, to the negative or to the positive in making a series connection. So you have to first make the measurements, then I can lug this cable. I cannot make it long, I have to make it neatly, and I give some allowance. So I have to first measure from here, then up to the last terminal. Then after making the measurements, then I have to cut so that this end I can lug, also this end I can lug this cable. Now we have made all the jumpers. We need to connect these 4 batteries to make a 24 setup so that we're having 2 sets, this set and an upper set. So right now we have set the negative. So we have to bring one spanner so that we can tie our terminal very well. So one terminal is already formed. This is a negative terminal. Then we are going down to the positive terminal so that we can make a 24 connection. Connect the positive terminal because remember the other up one is a negative terminal. Then we are going to connect the positive terminal so that we can make up a 24 setup. Positive, you see the red one. So this is the positive. So I have to bring my spanner so that also I can make this terminal very, very firm. Whenever you are making any terminal, you have to make it firmly, confirm that it is tightened so that you don't overheat the battery, don't spoil the terminals. So those are results when you don't make the terminals very firm. So right now, this set is done. So we are going to make another terminal for this connection of these 2 panels. We have finished to connect the batteries in a proper connection over 24 connection. So let me explain to you how we connect these batteries very well so that you can understand in details. So this is the first battery and this is the second battery. So this is one string. This is the first battery, this is the second battery, this is another one string. So we have got the negative terminal of this battery, then we go to the positive terminal of this battery. So right now we have made a 24 inverter connection. Then we are left with the negative and the positive of this battery. Same here, we have made a positive to the negative so that I can make a 24 inverter connection. So the left terminals, we made a parallel connection. So this connection, because we have one inverter over 24 inverter system inverter kilowatt. So we cannot make this battery make it in 48. So if we make it in 48, the inverter we might lose it instantly without any doubts. So what I've made, this is the connection. So the last terminals we have made positive of the first string, then to the positive of the last string of the another string. Still, the negative also to the negative of the last string. So we have maintained a 24 inverter connection. So right now we're going to use what digital meter or meter to see if what we have done is an inverter connection over 24. So let's go to do the testing and see if the system is right now. Okay, we can feed in the inverter after confirming. So right now this is the inverter. It is a 6 kilowatt inverter as I told you before. So right now this is a positive terminal, as you see is a probe. This is a negative terminal. So we are using an Inco clamp meter so that we can confirm before connect to the inverter that I have set a 24 inverter input. So as you see, this is a negative, I plugged in. So as you see close, it is showing 26. So right now, the batteries are full, so the setup is okay. So it's okay. We can plug in the inverter so that we can power the inverter so that we see it is powering correctly. So right now we are going to insert them here to the negative terminal of the inverter, also to the positive terminal of the inverter. We first use the terminal. Flexible conduit to help us to protect this cable from being scratched from this metal. So you have to insert it very well like this so that it can protect the cable from any scratch. Remember, this is a wire mesh. It can be very sharp at the ends. So you have to put this one so that you can protect the cable very well. You have to put every measurement of safety when you're doing installation. So we are putting the negative. So this terminal is tight enough. Okay. See how we are putting the positive terminal on the positive terminal of the inverter. Okay. So everything is okay on the battery connection. So this is a power button. Okay. So the inverter right now has switched on. So within a second, it's going to switch on. Now we are taking power from the battery to the load. So we are going to first test before connecting anything to the roads. So still we're going to use this clamp meter to test the output. This is the output terminals from the inverter. This is a negative, then this is a positive. Let's see what is it showing. Right now it is showing 232 volt, which means the output is okay. So we can go with the connection to the loads. Switch off the inverter so that we can connect the input supply. This section it is for input supply and this section for output supply. So we can switch off the inverter so that we can connect the system without any short circuit. So this is why our cable is ending. As I told you, this is a main switch. This is a four-way main switch. So this is where all the connections are going to be combined. AC breaker. This is going to be controlled on the side of inverter input from the mains. Still, this is a SPD. Also, it's going to be connected together with this breaker. Still, this one is going to help us to remove any surge which is going to the inverter to protect the inverter from over surges. This is the box where I'm going to put all these two breakers, the AC breaker and the AC SPD. So, right here, this is the cable where we're going to connect the input, also the output from the inverter. So we are planning to put this box here because we want to be close to this main switch. So right now, this is where our box is going to be placed. Then we have to first put the speed level so that we put this box on the level. So when we have marked our holes, as I told you, you have to do with this gadget so that you can make the work simple and professional. So we need this power drill so that we can make it in a short time. So you have to be careful so that because it uses much power. Then you see how it is simplifying work. So you have to do with both. The other big one, it hits the wall and make holes. So this one it used for tying any screws, making it unrelease and tighten the screws. So this one is a very good one, so that you have to purchase it and also purchase the other big one. Okay. This is the SPD. So this is the breaker which will be controlling the input to the inverter. We are going to cut our cable so that we start the terminations. So this breaker is going to be working like this from the main switch, and it supplies here to the input of this breaker. So this output is going to supply power to the inverter. So right now, this is the live. Still, we are going to also bond the SPD together with this output, which is going to the inverter. So right now we have connected the output from the mains, which is going to the inverter input. So still I have to bond the SPD together with the output power, which is going to the inverter, so that it can remove any surge which is going directly to the inverter. We are bonding it together with the output, which is going to the inverter, and also the live output of the SPD together. So right now we also are going to bond the neutral. So this is the neutral which is going to the inverter. You have to bond it together with the neutral of SPD. The output is already done, so we are going to work with the input which is from the main switch to the AC breaker. Still, we are going to also to burn the earthing from still from the main switch. So this is the live input into the breaker. This is the positive side out. This is the live side. Still, the input is not yet connected to the MCCB breaker because we are still dealing with this side. So still have to feed the neutral input at the neutral side of the breaker. I told you, remember, your breaker has to be every time still down so that you don't get any short circuit on any unexpected short circuit or in any connection when you are connecting. So I want to first put these cables a bit. So which is left, this is the supply to the inverter. So this is the supply from the inverter. Still, it is going to go in the main switch so that we are going to do the isolation of our loads, which has to be connected to the inverter. Okay, so this one is going to go straight. It has to pass through. It has to pass through here. So it means we don't need any breaker because these breakers are going to be controlling the output from the inverter straight to the breakers, which are going to supply the loads. So right now we have to put the insulating tape so that we protect from any short circuit. If you forget to put a proper insulated tape, you are on mess. So right here, this is going straight. So right now, which is left, it is the earthing cable, which is coming from the inverter. Also, this is the earthing cable, which is coming from the main switch. So this is the one which is bringing. So we are going to burn this one with the SPD. So the SPD has to be burned with the earth so that this surge which is coming from the inverter has to be taken to the earthing system so that you can remove this surge which is going to be affected to the inverter. So now the connection now it is done. SPD is well connected, the breaker is well connected. So now we have to cross the box. Yes, the connection is very clear. So still we have to leave this breaker still down so that we are going to work also the isolation and also the supply to the inverter, also the supply from the inverter. Right now, we are going to first connect the earthing to the earthing point. So this is the earthing terminal. Remember, you have to first connect the earth so that the inverter, that every connection is earth so that you don't get any shock. So the earthing is done. So every termination is earthed. So which is next? We are connecting the neutral. So everything is very firm. So which is left? We are left with the live supply, which is going through the breaker, then it enters in the inverter input. So this is the breaker. Only it is down so that we don't expect any short circuit. So now it is properly inserted. So which is left? This is the cable. So we are going to supply these two breakers. So this breaker is controlling the lights and controlling all the sockets. The live output from the inverter is now connected. You see the main is off, but everything is working very well. You see everything is very fine. So these two breakers are for inverter output. So I'm going to show you how everything is working with the inverter supply. Okay, now we can put the main supply to go to the inverter. So also this breaker, we can put it up. So this section for now it's completely set up. So we can go direct to the inverter, then you'll see the performance of the inverter and also the components we have connected, lights, everything which is working in the inverter so that we can handle the system to the client. So it is receiving grid as you see here. It is taking it directly in a bypass mode to the load directly, then plus charging the batteries until when they are full, then it can keep them at a standby. When power goes off automatically, it will be getting power from the batteries, then it back up the cafe bar. I'll help you. Okay. So right now we are taking a step of programming this inverter, because right now, as I told you, we have to get batteries, so we have to insert them in the program. So right now it is a AGM. If I take you through all the programming for the battery, this is for the batteries. Here we have put it there, so we don't need to put in there. So we don't need to put in for the batteries only as battery. This is used. So you have to put in. This is the lithium. So you have to go until when we find AGM. So this is a free maintenance battery. These are good batteries. So this is the it's programmed where to be programmed in. So now we can enter, then we can insert the program. So we can go in through. So we check the output voltage, it is 230. We check the charging current, it is okay. Then we check the battery, they are 23. So we check the floating percentage, floating voltage, sorry, it is 27. Then it is going to be only using solar and the utility. So in the future, this system it can use solar plus utility. So we just program which is the first product to use to be charging. So right now we are only going to use the mains or the memory, or what we call the mains or the grid to charge the batteries, because right now this inverter is using mains to charge the battery. As you see, it is using AC from the main supplies. So that's why it is using only power to charge the batteries plus giving the power to the loads. Okay. So right now the entire cafe is working proper. It's called cafe bar. So the inverter is effectively working very well without any problem. If you look around outside, everything is in order for the system to be performing very well. So everything is working very well. Well, it's night, but everything is very well working. So this is how our inverter proper working. The entire coffee bar is working very well. This is a display fridge. So without any friction from the motor, it is working perfectly without any sound. You see cakes, you see drinks, they are there. So inverter is making a big work to put these drinks and these cakes